This video covers the square root property for solving equations. So first, we're going to just take a look at what that is. So we know when we have, for instance, the square root of 25, we're just going to take the principal root, which would be 5. But if we have a situation like this where we're solving, we would have, if we have, for instance, x squared equals a, then x would equal plus or minus the square root of a, because it's whatever would make that true. So we could actually plug in x equals negative square root of a, or means and or in math, the positive square root of a. So for example, if I had the x squared equals 4, x could be plus or minus 2. And sometimes we would only choose the positive because it makes sense to the problem. Sometimes if we're solving in different ways, we have applications, we have to make choices there. So quadratic equations, you've probably learned about these before. This is why we do, a lot of the factoring to figure out like where our intercepts are. Square root method is a way to do that also. So what we're doing here is this kind of the simplest setup. When it works out nice and neat, we can just jump right to this. Another thing we can do is complete the square, and also quadratic formula is something you may have seen before as well. So we're going to explore these different methods. Now again, I'm not going to do all of these. I might do more than usual on this because I do have a virtual classwork companion for you to work on as well, for some extra practice, because this probably is something you haven't really seen before or done before, so we want to spend a little more time in it. So the first thing we have here is 5 plus 16x squared equals 69. Now if this was some kind of word problem, it might say, when does the curve hit 69 on the graph? Like the y component would be 69. In order to do that, we need to set the equation, we want to set it up so that we can solve for x. So we're going to use the square root method because we have a square term and then we have a constant. So this is the type that will work out really nicely for this case. And we'll be able to just take the square root of both sides and solve. We've done that with like kind of simpler things, but not having to rearrange. So here we're going to subtract 5 from both sides. And we'll end up with 16x squared equals 64. And you can see these are going to work out really nice for you, that they are perfect squares. So then I'm going to take the square root of both sides. Actually, I could do that on this one because 16 is a perfect square, but typically we want to, it's easier to divide by the coefficient first, then you don't have to mess with it. So let's do that. Actually, we're going to divide by 16 on both sides. And we end up with x squared equals 4. And then we take the square root of both sides. We could have done it earlier on this particular case, but it doesn't always work out that way. So then the square root of x squared is x, and that plus or minus square root of 4 would be minus 2 or 2. So that is our answer. We can write that as a solution set, minus 2, 2 with braces around it, or just x equals minus 2 comma 2 is fine also. Okay, so that is basically the process. You could plug it back in to check, make sure it works. I'm going to have you do number 2. You can do that as a try it. It's pretty similar. If you get stuck, just, come back and look, but pause the video and do it on your own. 81b squared minus 4 equals 0. So the process for that would be add 4 to both sides, and then divide both sides by 81. Again, this one you could have done it a little differently, but we're going to follow this process. Divide by the coefficient and then take the square root of both sides, just so you really get in the habit of that. And then your answer is plus or minus square root of 81, and comes out to be b equals negative 2/9 or just positive 2/9. I'm going to quickly go through number 3. 3x squared plus 2 equals 242. You can maybe just try this one on your own too. So I would have 3x squared equals 240, because I'm going to subtract that 2 from both sides. So I'm going to divide the 3x squared by 3. So this is a case where you really have to do it because we don't have a perfect square. So then I'm going to get x squared equals 80. Take the square root of both sides. So we have plus or minus square root of 80. And then we need to use our skills of simplifying radicals that you learned before and loved so much. So we're going to go through that process here. We have x would equal, I'm just going to pull aside here. So we have square root of 80 is the same as 16 times 5. I'm figuring out perfect squares that line up. If you didn't know that, you could break it down into its product of primes. So we end up with a minus 4 square root of 5 or positive 4 square root of 5. And again, in math, or means and or. In this case, if there's no restrictions, it would just be both. Number 4 is a little bit different. Why don't you start that one out and see what happens. So the problem is 2a squared minus 3 equals negative 13. So start by adding the 3 to both sides and dividing by 2. So we have 2a squared equals negative 10. And then we divide both sides by 2. So we want to isolate our exponential there, the a squared. So we're left with a squared equals negative 5. Then we take the square root of both sides, and we have a little bit of an issue here. We have a equals plus or minus square root of negative 5. Well, there's nothing that we can find that would give us that. So we have no real solution. It would be an imaginary number anytime you get a negative under the radical sign. So we're going to just write no real solution. Now, some of you may have worked with complex numbers before, but they are not in the scope of this course, so you would just write no real solution for these type. This next section looks at the zero product property, which you've probably seen before. And what this says is if a times b equals 0, then a must equal 0 or b must equal 0. So no matter what the answer is, it if one of those factors, like here in example 5, if one of them comes out to be 0, then you're done. You would equal 0 when you multiply. So number 5 says k minus 5 quantity times k minus 2 quantity equals 0. So you can kind of do this in your head. If k were equal to 5, then I would have a 0 here. And the other factor would come out to be 3. 5 minus 2 would be 3. So 0 times 3 would be 0. The same thing if I put a 2 in, that 2 minus 2 would come out to 0. And even though I have a number that works in the other factor, I'd have 2 minus 5 would be negative 3. I'm still going to get 0 because once I multiply, that's how 0 works. So to set this up and show out what I'm doing, I would just set each factor equal to 0. So k minus 5 equals 0. Or, again, that means and or, k minus 2 equals 0. And then I would calculate that out. Just, solve and go through your steps. You can pretty much do it in your head though. K equals 5 or k equals 2 would be my answers. If I could write it as k equals 2 comma 5, or I could put it as a solution set with a brace, 2 comma 5, another brace. Now, for these to work, you have to have your equation set equal to 0. Unlike the square root method, you would have your square, whatever, that variable to the second power, equal to a number. This one is very specific that you would have the equation set equal to 0, then factor it, then set each factor equal to 0, and solve each factor. And if you put those back in, you could prove out, we already kind of did that, that the equation would equal 0. And if this were a graph, it would be hitting on the x-intercepts. That's what that means, when the y is 0. That's my x-intercepts. And those are really important. They tell us a lot of information about the data. We'll get more into that later. So number 6, you can try that one on your own. So you're going to have to factor that first. V squared minus 3v equals 0. So factor it and set each factor equal to 0. Okay, so I factored this. V times quantity v minus 3 equals 0. So set each factor equal, v equals 0 or v equals 3. And that is my answer. Number 7 is a little different, so I'll go through this one with you. But if you feel comfortable, you can try it yourself first. It would be add 12 to both sides, set equal to 0. X squared minus 7x equals negative 12. Okay, so this one I've added 12 to both sides, set the equation equal to 0. So I have x squared minus 7x plus 12 equals 0. And now I just need to factor that up. My factors of 12 that would add up to 7 would be 3 and 4. So my binomials are quantity x minus 3 times quantity x minus 4 equals 0. Set each factor equal to 0. I get x equals 3 or 4. Okay, one last one on this type. You could try this one yourself. It's already set equal to 0. So go ahead and factor it and solve. It's a little trickier though because it has a coefficient of 5 on the lead term. So it's 5m squared plus 3m minus 2 equals 0. So try that one and then check back. So on this one, it factors out to be 5m minus 2 as my first binomial times quantity m plus 1 set equal to 0. then I just go ahead and solve that. This one's a little different because I have a coefficient on that m, so I do need to